Well, hello friends. Welcome back to the program. Today we're going to continue working on our JIT compiler for libjs, and we have a couple of little tasks and things that we need to take care of because over the last couple of videos, people have pointed out some little bugs that I introduced. So today we're going to take care of those, and I'll also want to look at factoring out the assembler from libjs so that we can use it in other parts of the system. So a little bit of housekeeping today, but should still manage to make it interesting, I hope. So we'll start with the one of the bugs that we introduced in the last video when we implemented a fast path for int32 less than comparison. So you're comparing two int32 values. If one is less than the other, then I made the silly mistake of thinking I can just compare them as two 64-bit registers, and I neglected to consider the sign flag correctly. Because if you're comparing two integers, as long as they're positive, that's going to be fine. So 2 less than 3, of course, is true, but -2 less than 3, you would think it's true, but we say false because we are kind of just neglecting to look at the sign flag correctly here. So we need to fix that. And I think the fix is just before doing a less than compare of the two registers, we're just going to sign extend them, which means that since they're in 32 values, lurking inside of a 64-bit register, the bottom 32 bits are assigned 32-bit integer, and we just want to take the sign bit from there and just smear it all over the upper 32 bits of the register so that assigned compare will then work as expected. So what we need is not that. We need a sign extension 32 to 64 bits. For both of these registers. So we're just going to add something for that. And then once you've done that, comparing them should work, should have the expected results. So sign extend 32 to 64 bits. And yeah, we'll just implement it as a move sign extended double word into quad word reg as 64-bit, reg as 32-bit. Can I get a assist here from Copilot? Yes, I can. Thank you very much, Copilot. Really appreciate you. Okay, so with that, I would expect -2 to be less than 3. Yeah, exactly. So it really is just that simple. So that gives us first fix. Libjs JIT sign extend integers before fast path compare before less than fast path comparing and less than fast path. That's pretty good. Okay, and then a bunch of people have pointed out that I neglected to restore the accumulator register in the put by ID and put by value instructions. So let's make sure that we do that. That was because I think I even talked about it while working on the code, and then I just totally neglected actually doing it. So both of these, they need to restore the value of the accumulator to its original value because of setters. Because if you have a setter and you put a value into a setter, that means that we'll call the setter function, which then runs arbitrary JavaScript, which will clobber the accumulator. And when we continue executing after the put by value or put by ID, we expect the accumulator to be unchanged. So we have to, in order to maintain that invariant correctly, or maintain that behavior, we have to restore the accumulator. So thank you to all the people who pointed that out. I really appreciate you looking out. It is funny to make these videos and then like a whole bunch of people point out the little mistakes. which I really appreciate. But I would give you the tip that if you are about to spend a bunch of time explaining something I did wrong, you can look in the comments and see if somebody already did, because I sometimes get these long explanations of what I did wrong from multiple people. There's a bit of a duplicated effort. Nevertheless, I really appreciate it. So let's see. Let's just make sure that we do those. libjs, JIT, preserve the accumulator across put by foo. This ensures that we don't clobber the accumulator. Putting a value to a setter. Yeah, so this will be how the put by ID, the bytecode interpreter handles put by ID today. As you can see, it does its thing, and then finally it restores the accumulator to the original value. Same for put by value. So yeah, now we're back on track with that one. And that's pretty good. And I feel like then I wanted to factor out the assembler, right? So that would be a big chunk of housekeeping. So the assembler has a little bit of libjs specific stuff with regards to basic blocks. So it'd be nice to get rid of that so that it becomes like a completely libjs independent thing. And then you can take this and write JIT code for other parts of the system, which would be kind of cool. So it has these APIs for jumping to a basic block or jumping conditionally to one basic block or the other. And we just need to get rid of those so that they don't exist, because if they don't exist, we have no more references to libjs inside of assembler itself. So let's delete them and then see what we have to do to make the world work again after we've done that. So compiling a jump, we can no longer just jump to a basic block, but instead we have to jump to something. And what we can jump to is a label. So that's kind of the assembler API that we have. So I think we're going to just add a mechanism where you can get a label that refers to a basic block from the compiler. So we would use it in some kind of way, like instead of doing this, we would do something like block label, or like label for, or something like that. Label for block. Label for is kind of cute. Jump to label for. Yeah, we can do that. And then how would label for work? Well, it would be, let's see how it would work. We need a assembler label for a bytecode basic block. And kind of like that, but I think we're gonna want to have some kind of struct, like block data or something like that. Basic block data, let's say. And we will store an assembler label in here. We can also store the offset of the block itself in the instruction stream. Start offset, let's say. That's where the block machine code starts. And then once we have that thing, we can make a hash map of basic block pointers to heap allocated basic block data, which means that they don't move in memory since they're on the heap, which is very nice because then we can vend references to the label without worrying about that. And then here we just need, I'm gonna say block data for block.label. Yeah, exactly. And then block data for, can you guess what I'm gonna do? That's pretty good, but I think I would write it using ensure instead. So let's see, return. What is this yellow highlight? Oh, it's some clang tidy thing. Ensure block, and then a lambda that returns a new value if we don't have one. Aha! Yeah, that's pretty good. Okay. So now we have a way to get a label for these things. So jump conditional has to work in the same way, but jump conditional doesn't exist anymore. Which I guess means that we have to, wait, what does jump conditional even do? Jump conditional. What did it do before I deleted it? It looks at the bottom bit of something. Okay. So if, wait, what are we doing here? We're loading the accumulator into GPR1, and then we do a toBoolean. What is the end result of toBoolean? toBoolean destination. We AND off everything but the bottom bit. What do we do in the slow path? Return a bool. Okay, so it's either 0 or non-zero in GPR 0 at this point. So I think we can actually do a, I guess we can do a jump if equal, just compare it to 0. So if it's 0, we jump to the false target. Yeah, exactly. Otherwise, we jump to the true target. That's pretty straightforward. And then finally, we need to do something about this guy, which is just a jump, so we can use label for here as well. Cool. Now, of course, this is not going to work until we actually hook up those blocks and labels and things. So how do we do that? We do that in the main loop, I think. So the main compiler loop here, when we enter into a new block. Oh, right. Previously we were storing metadata in the basic block itself, which is part of the bytecode object graph. And as this fix me says, this is JIT state, and it shouldn't be part of basic block itself. So I think we can just kick all this stuff out, and basic block goes back to being just a basic block without JIT state. And then we get a bunch of errors here that we need to deal with. So block offset is no longer block offset. It is block data for block dot offset. No? Oh, I need something like that. Start offset. There we go. For absolute references to here. Oh, right. That's for like the exception handlers. We need the final 64-bit address of the code that we need to jump to in case of an exception. I think we can store those in the block data as well. Block data for, and then we just need to have a vector of size t. Absolute references to here. I think that what it was called. Yes. Okay. So once we have that, when we want to patch up all the jumps, we can iterate all the basic blocks, and then we just need the block data. So we get block data for block, and actually we don't need to patch the jumps anymore. We can just say to the label to link, although link as it works currently just links to where you are in the assembler output right now. So it links to like the point where we're currently emitting code to, but this runs after we've finished emitting code. So we need a new API, link to, and like, yeah, block data start offset, exactly. So it's going to link everybody who wants to call to this label or jump to this label, they are going to be jumping to start offset. It sounds good. And then the absolute references, blah, 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 are in block data now. And that's start offset in block data. Okay, so we just need to implement or invent the link to API. So I think we can essentially, make link implemented in terms of link to. Assembler and output size. Yeah, so link continues to just link the label to the point where you are in the output currently. Offset of label and instruction stream. It's the name of the member. Oh, I'm going to call it link offset, whatever. So we do that, and then somebody's messaging me, but it's okay. Not right now. Okay. Okay, I wonder if this will still work. Man, test.js is a little bit in shambles. Seems like crashing at the end here. Can we run our normal stuff? Yes, we can. Okay, that is good. And -2 is still less than 3, of course, as expected. So that's great. That is great. So let's get rid of that. Yeah. libjs, JIT, move, move basic block specific, basic block state from basic block itself into compiler. We'll all refer. You know what? This should be multiple commits. What am I doing? Yeah, that was really sloppy. So let's try again. So what did we have? Removing the stuff from basic block. We can do that last. Improving the, let's see, assembler APIs. Jump conditional, yeah. So I guess actually the thing we could do is we could change the implementation of, no, everything is kind of interconnected with that stuff, but we can leave that one out. I want to have just the link changes we can take. Okay, so linking, we'll leave linking in. Yeah, and then label 4, we can do all of this stuff. Yeah, these are really nice. And then we remove those things last. Yeah. So this is let compiler keep per basic block state internally. Instead of no, JIT compiler now has, or compiler now has a struct per for each basic block. The struct contains an all the stuff that we previously stored with the bytecode, with the bytecode basic block. code. This with this change, we become independent. Or no, that's fine. That's fine. JS, remove connection. Remove all interactions between assembler and basic block. With this change, assembler is now free from libjs concepts and could move out to its own apartment. Cool. That's great. I wonder if we can do something about test.js, because it is asserting, and I suspect that that's going to be the fix me I left here, because we're expected to throw when calling sometimes, and I just didn't finish that. So I think we can just uncomment this and deal with it, because there was some issue with this. What does this API want? Right, it's templated and it wants a pointer to the instruction. Okay, so instead of doing that, let's just find out what kind of stuff this thing wants. So remove the template instantiations. And then here, instead of taking call, we want call type, and yeah, okay, so just call type, and then we want to pass call to throw type error for callee, auto call. Well, what if we didn't have that? We would want the callee instead. Yo, and we also want the expression string. So what's that? Like a optional string table index. It's like if we know which expression you try to call, then we can, I think we do like a slightly nicer error message, basically saying that like, oh, you try to call this piece of code, but that doesn't work. Something like that. Okay, so if it looks like that, we're good. And then here, we need to pass the callee. No, wait, what do we want to call? Callee and the expression string at the end. Oh, I don't have the expression string, of course. Yeah, you would hand it to me? How nice. Great. And then where I call this, throw if needed for call. Let's just make sure the header looks correct. Sure, throw if needed for call. In the interpreter, throw if needed for call. Instead of passing this, we now pass the call type and the expression string. Yes. Okay. Right, and then we have to fix that in compiler as well. So we can't pass this. We want to pass the call type and the expression string, which I don't have here. So I would have to pass that, but I'm out of arguments. Okay, I don't want to figure out how to pass more arguments right now. So I will just give you a slightly worse error message for now, and we will still have a fix me. I get the expression string here as well. But if we just do this, yeah, okay, so test.js runs. That is great. Does it run to completion, I wonder? It does. We have some errors. but I think that's probably okay. JIT compilation. Let's see, if we just don't have all of this spam output, maybe life would be a little bit less confusing. So let's see what this looks like without all the spam. Hello, okay. Is my computer okay? Okay, I think so. Yeah, so we got some bugs. Oh, there's some spam I forgot to remove. Yeah, so we have some issues with try catch finally. Might be some issue with ternary operators. Yeah, got a couple of different things to look at. But on the whole, this isn't very bad. This is pretty good. Okay, so let's just commit this change. We can do the interpreter change independently. Actually, let me see that I didn't break the libjs. No, JIT. I didn't break that in any way. No, unjitted version still working just fine. Untemplatize, throw if needed for call. And then we can call it. libjs JIT invoke throw if needed for a call in cxx call. Let's reach the end of this. This allows test.js to run to completion, though we do still have some bugs to track down. Okay. Great. Yeah, there are definitely going to be bugs with try catch finally, because I only did basic try catch. I did not implement finally fully. So that's a thing. But this puts us in pretty nice shape. I guess we could even yoink out the assembler at this point and just move it. Could just move it to something else. Like I was thinking we could move it to libjit. Libjit. Wouldn't that be nice? I don't know what else we would call it, so libjit. Libjit seems good enough to me. Libjit. It's going to be a little bit of namespace confusion there since we have JSJIT and libjit, but maybe it will still be okay. And then assembler. All right. And then we have to say that we want to link with libjit. And then this is going to be a very short file. Unlike the libjs CMake lists, oh my goodness, so much stuff in libjs. Libjit does not need much stuff. Do you even need anything, my little friend? I want to say libcore, but I think he doesn't even need libcore. It needs to pull in acc from somewhere. I guess it probably comes from libcore. Can't find source file. Oh shoot, did I not move that? Wait, what? Oh, right, I have to remove it from the libjs file. libjs JIT assembler. Okay, so now you guys get to be like that, and libjs becomes libjit assembler. Is this going to become super annoying, I wonder? Maybe we should do something like using JIT assembler. I think that's okay. Then we don't have to deal with that. Okay, and oh wait, I need to edit some makefile for logom as well. Libraries, or what is it? There's like a list of the libraries somewhere in this file. Where is it? Logom standard libraries, right? So JS, you also get to have JIT. There we go. How very nice. Okay. That's good. JIT plus libjs move. JIT assembler into a new libjit library. This will allow other components, other system parts of the system to generate machine code at runtime. Okay, great. That is pretty good. So that's probably not the way it's going to look in the very end, and maybe we'll bring over some more helpers. Like the assembler is still pretty goofy in that you have to give it a vector U8. So we can probably add some more helpers and stuff, but at least having it in its very own library makes it much better separated than it was before, where it was like tied to libjs, and now it just isn't. Of course, it is still tied to x86, but we should be splitting it in such a way that it can generate machine code for any architecture. And we'll see how that works out in practice, but I think it should be reasonably doable. I haven't been using any super crazy x86 specific things. But there are definitely x86 isms in here that need to be adapted for other architectures. We'll deal with that when we get to it. Okay, great. All right. I think maybe we will. I was gonna say let's leave it here for today, but I'm tempted to do just one more thing, something fun also. Since we were doing all this good boy chore stuff today, I've been meaning to look at some of the instruction encodings that we do and see if we can make them a little bit smaller, because we do generate very, very thick, wide, large machine code, and we could do a lot better with that. So let's just look at our loop program. So we have this loop program where we JIT this function in particular, and let's see if we can take a look at the output and find something we could slim down a little bit, because that would be just something nice to end on, because this generates hex 3 CD, which I don't know off the top of my head what that is. 973 bytes, so almost a whole kilobyte worth of assembly code or machine code for that loop. And if we look at you can see the instructions, how they're encoded here on the left side in the second column. You can see that we have a lot of zeros, and that is because we keep using 32-bit immediate values. We're passing 32-bit immediates to a lot of things, and I've been meaning to just look at these and see if we could compress and like use 8-bit immediates whenever the value we want to supply fits in an 8-bit value. So I think there's a lot of different instructions where we could do that. This is another nice one. When you're moving 0 into a register, we could do the old Intel XOR trick, where you XOR the register with itself to turn it into 0. That would definitely have a shorter encoding than that. Maybe let's do that one. An assembler. So if you're moving, let's see, how would we do that? We can do like a fast path or whatever here in the generator. So if destination type is actually, yeah, I was gonna say if destination type is register and source type is an immediate 64, that's the only immediate we have. Okay, so if the where does that go? If the source immediate is 0, yeah, XOR dust with dust. How do we generate that? Still need a rex prefix and then XOR register with self. We can return here, right? So let's see if that generates what we expected. Right, so now we get XOR RAX with itself, which makes the instruction a lot shorter, so it doesn't have those trailing 4 bytes of zeros anymore, and our program is now 3BF. What was it before? 973 bytes, I think it was. So 3BF. Oh my god, that's not what I wanted to do at all. IBase 16. 3BF. 959. So we've shaved off a little bit. And then yeah, we can like keep doing stuff like that, right? Where I mean, we have all these mobs here with a displacement that is, if the displacement is 0, we don't need to encode the displacement as a 32-bit displacement. That could be 8-bit displacement for sure. So let's see, let me do a commit out of this one. Oh no, this is libjit now, libjit. Code mov reg 0 as XOR reg. This uses less space for the same result. Yeah. And what was the other one I wanted to do? I already forgot. It was the displacement thing. Right, all of these guys. So if you're moving to a memory location from a register, let's just do that one quickly. So mov from register to memory location. And here is our offset or immediate, always as a 32-bit inline displacement. But I think if the offset or immediate is, if it's less than or equal to 127, I guess. Offset or what is the type of that thing? Okay, let's just do it like this. If so, we can do it like that, and then it would also we need to emit the thing as an 8-bit displacement like that. Because you think you can have sign displacement, so we would need to mess around with that also. Make sure that we don't screw it up. But let's see if, does that work right? Okay, yeah, so now when we're moving to R13 plus 0, we encode that as this short form with a 1 byte displacement. That's pretty cool. We can do the same in the other direction also when you're moving from memory to a register. So if source.offset or immediate, and then it's just the same thing with slightly different, yeah. Okay. I just wanted to close out with something kind of fun here. And that still runs, and now we're at hex 332, which means that now we've saved well over 100 bytes in our machine code that we're generating. That's pretty good. It's definitely good to make your machine code smaller when it's super obvious, straightforward things like this. Like, of course we should do them. Because the smaller our machine code, the more of it can stay in cache at the same time, right? There are things that are harder to do, like jumps, for example. There are shorter versions of jumps. So if you know that you need to jump like you need to jump relative to the current location, and you're doing a small jump to really nearby, you can encode the offset in 8 bits. But the problem is when we're emitting the jump instruction, if it jumps forward, then we don't know yet where the target is. So we don't know yet how far away it's going to be. So that is a little bit harder. And you would almost have to come back afterwards and try to compress the jumps. So you could like write a jump compressor, I guess, that would just iterate over the code at the end and see, oh, these jumps can be squeezed into smaller sizes, and then you have to update all the offsets of all the subsequent jumps because the code shifts around. So it's a little bit non-trivial. Or maybe there's some really clever technique for something like that that I just don't know about. Okay, let's just commit this one. So the JIT emit 8-bit displacement variant for MOV when possible. Sure. And there was some more little thing that I noticed. Yeah, compared to 0, I think for those we can compress those as well. Because if you just want to know if a value is 0 in a register, you can do test. You can test the register against itself, which means that you're ANDing it with itself without storing the result. And then if the value is 0, then the 0 flag will be set after a test RAX here. And that would save us 4 bytes every time this happens because we don't need a immediate value. So I think compare, like I wouldn't change the way compare works because, you know, you might be interested in some other part of some other flag, like the carry flag or overflow flag or whatever. But the way we're using compare, jump if not equal. So we don't know if we're testing for 0. I guess if we had something like that. So we have jump if equal. What if we had jump if 0? So reg. And this would do like test reg. And then, yeah, JE, JZ, they're the same thing. That would be kind of sweet. And do we use that? So compare, no. We have that toBoolean thing. How do we use that? Right, so we have jump if equal, which does a check like this. So this thing could be simplified into a jump if 0, which we can then do smarter in the assembler. And maybe you couldn't, maybe another architecture doesn't have a way to do that smarter, but at least by having an API like this, that allows the assembler to decide if there's a better way to encode that. So let's see, jump if 0, which we can then encode. Let's see. Now I'm thinking like jump if equal. I guess we could do stuff like that here too. Like if it's immediate and it's 0, then do jump if 0 instead. That kind of stuff. If it's immediate, then jump if not 0. Yeah, exactly. Jump if not 0. Okay, thank you. Then we just need to implement test. So test, very similar to compare, but not exactly the same. Let's see if Copilot can fill that in. No. Retrieving completions. Yeah, somebody told me to look at the little spinny thing in the taskbar if I'm waiting for Copilot. So let's see, test reg. So RHS there and there. Let me just see that the encoding looks good. Yeah, I think that's probably good. So what did we get now? Did we get these tests? Yeah, test RAX. And yeah, as you can see, they are shorter. They're missing the 4 trailing bytes, which puts us at 316 hex. So now we're down to 790 bytes. So we've shaved off quite a bit. And there's probably more we could do. I mean, there's definitely more we could do, but I don't have any super immediate things I would like to do. Oh, wait, that reminds me, somebody told me to do some other thing. But what the heck was that? Let me just commit this at first. There's one more thing I think that somebody pointed out. Let's see. Actually, you know what? Let me do this as 2 separate commits. Lib.jit add jump if 0 and jump if not 0 to assembler. These can use test reg on x86, which gives us a shorter output, shorter encoding. Yes. JIT, use JIT assembler jump if 0 to improve code size. Sure. Finally, right, so there was something about the way we increment, I think. Right, what was that thing? What was that thing? It was about incrementing. Right, so the fast path for increment was doing a bit of stuff that it doesn't need to do. So somebody suggested that we could just remove a bunch of stuff from here. So let's look at what the fast path for increment does. So first we load arg1 with the accumulator register. And then if arg1 contains an int32, then we go here where we mask off the bottom bits of arg1. And then finally, or then put the result of that mask goes into GPR0. Okay, so all of this is just masking off the bottom bits. And then if the bottom bits are 7FFFFF, then incrementing will overflow, so we go to the slow case. Otherwise, we add 1 to GPR0, and then add back the int32 tag that we masked off up here. We OR that back in, and then store the result in the accumulator. So what somebody pointed out was that we don't need to do all this. We don't need to mask it off. Because well, wait, what was the thing? We still need to mask it off, right? But because we want to look at the bottom bits to see if they are 7FFF, but we don't need to do this where we shift the thing back in. I think that was it. Because instead of adding to GPR0 here, we can just add to arg1. That's where we have our original value. Because it already has the int32 tag set in the topmost bits. So here we would just do arg1 plus equals 1, like that. And then we can skip this stuff and that stuff and just put arg1 back into the accumulator register. But I think we still need to do this part where we check if the bottom bits are 7FFF, because that would be our overflow condition. There's probably a smarter way to do that also. But still, this definitely saves a couple of instructions, so that's good. Still runs, and now we're down at 309. Where were we? We're at 309 now, so 790 was the last one. 777. Nice. Down to 777 bytes for this. Yeah, jump compression would be cool. And we can just do better instruction sequences for a lot of things as well. Should definitely be possible. But one thing at a time. Okay, so libjs, JIT, simplify the increment fast path, and 32 fast path. Since we know the value, when we know the value is a positive in 32, less than 7 FFFFF, it's safe to just add 1 to it and use that as the final result. This avoids the work of re-adding the int32 tag. Yeah, I forget who suggested that, but that's a great simplification, so thank you very much. And I feel like there were probably more people who suggested other simplifications, but I forget what they all were at this point. And we did a whole grab bag of things today. And I feel really good about where we got to. So let's see if we turn off the IDE. I'm just curious if we can just get a quick measurement of of where we are with the performance on that loop program. Yeah, 317 milliseconds. That's pretty good. I wonder if the thing we just did, like, did that improve performance? Where were we now? 312. Let me do a couple of warm-ups here just to see if we can stabilize the number a little bit. 3-1 something, definitely. Just that last change. Wonder how much of a difference that would make. Okay, well, nothing too crazy. Nothing measurable, apparently. Even so, less code is good for me. So let me go ahead and do that. Yeah, so this will be the end of today's video. And if you made it this far, thank you so much for watching, for hanging out. I hope that you saw something interesting. Today was definitely a bit of housekeeping work. We did fixed a bunch of bugs that had accumulated. We factored out the JIT assembler into a libJIT, which in theory makes it available to other parts of the system that want to do JITting. We made it possible to run test.js to completion. That was very good. And then we still have bugs to fix there, but we'll get to those eventually. Then we worked a bit on code size optimizations to generate smaller instructions for the same, that would have the same effect. So I think that was really nice as well. And yeah, we also adapted, or we also incorporated the fast path improvement for increment that somebody suggested. So thank you all to everybody who suggested improvements or pointed out mistakes. If I made mistakes today, please point them out. I really appreciate it. But I think this JIT is definitely getting to the point now where I think time is coming to put it into the master branch and invite more people to work on it, which would be really, really nice. Just have to do a little bit of tinkering so that it's not enabled by default for everybody, because obviously it doesn't work perfectly yet. But it's going to be really, really interesting to open it up for more people. Anyways, this is it for today. So thank you all for hanging out. I will see you next time. Bye.